Good morning, students. Today we will start from next chapter of chemistry, that is carbon and its compound. It is also known as organic chemistry. Students, we have chemistry in three branches. Three separate branches are there. One, it is physical chemistry. Second is inorganic chemistry, and third is organic chemistry. Physical chemistry, we have already discussed many chapters like mole concept in 9th class, and inorganic chemistry, many chapters like chemical reactions in 10th class, metals and non-metal, acid basis salts, periodic table, and all like these chapters, all related to chemical reactions, they all come under inorganic chemistry. Now this is the last branch, organic chemistry. It is related with the carbon and its compounds. That means there is a separate branch of chemistry which is given to the carbon and its compound to study these compounds. It has organic chemistry. Then what is special about carbon? Why carbon has been allotted a special branch of chemistry, that is organic chemistry. Let us understand why the carbon is special for all the elements of the chemistry. Our chemistry has total 118 elements, but still carbon is unique. Now this is the first topic of your chapter, unique nature of carbon. Now first unique nature of the carbon is from its electronic configuration. Carbon atomic number is 6, electronic configuration is 4. That means valency of carbon is 4. That means the first property, it is tetra covalency. It means carbon has 4 electrons in their outermost orbit and it can share all the 4 electrons very easily, but due to 4 electrons in the outermost orbit, it is unable to donate all the 4 electrons. It cannot donate and cannot gain 4 electrons from outside. It cannot. Why? Because it has no sufficient energy to either donate or gain electron. That's why it has the only option to share all the 4 electrons with the other elements. That's why this is the first unique nature of the carbon, that is tetra covalency. Tetra means 4 and covalency means it can share all the 4 electrons easily. Now the second unique nature is known as catenation. Catenation means self-linking property. This self-linking property of the carbon helps it to form long chain of carbon like this, or branches of the carbon like this, or closed chain of the carbon like this. That means carbon can link itself to form long chain, branch chain and closed chain. These open chains are also known as aliphatic hydrocarbons, while these closed chain are also known as aromatic hydrocarbons. Because of these two special unique properties of the carbon, this carbon have special branch to study, that is organic chemistry. Now, other part of the carbon, that is allotropes of the carbon. Allotrope, the general definition for the allotrope, it is the form of the elements in which it exists in nature. That means if the element exists in more than one form of in the nature, that is called allotropes, and the property of these elements is also known as allotropy. Now, for example, carbon has two main allotropes in nature. One is amorphous and second is crystalline. Amorphous means these type of allotropes, they have no geometrical shape. That means these particles have no regular geometrical shape, that is called amorphous, while crystalline, they have regular geometrical shape. They are known as crystalline. Now, amorphous is further of mainly four types. One is coal, coke, charcoal, and lamp black. While the crystalline can be of three more types. One is diamond, second is graphite, and third is fullerene. And how they are different from each other, let us understand with the help of their structures. First of all, diamond. Diamond has the tetrahedral structure, and this tetrahedral structure, each carbon atom is attached with four more carbon atoms. That's why this structure is known as tetrahedral structure. In these type of structure, no carbon is free. That's why it has no free electron also. That's why diamond is a good insulator. But in case of graphite, each carbon atom is attached with three more carbon atoms, and each carbon is free. That's why it has free electrons. That's why graphite is a good conductor. Let us see how they are free. Suppose this carbon atom is attached with this carbon, and this carbon is attached with this, and this one this. In this, you can say this carbon is attached with this 1, 2, and 3, and this fourth carbon is free. This fourth electron is free, and it means each carbon has one free electron. That's why graphite is a good conductor, and this type of structure is also known as hexagonal structure. And now let us come to fullerene. Fullerene has 60 electron of carbon. They are arranged in a football nature, and which has 60 and sometimes more than 60 carbon atoms are attached. They are generally helps in making special type of insulator, which is making electrical switches. Now come to next part, that is bond. First of all, what is the meaning of bond? Bond means the force of attraction between two or more elements to acquire stable configuration. That means whenever two or more elements come together to complete their octet, this force of attraction is known as bond. This bond can be of two main types. One is electrovalent bond, covalent bond, and second one is electrovalent bond. Electrovalent bond is also known as ionic bond. Now, what are the main differences between covalent bond and electrovalent bond? Let us discuss. First one, covalent bond is always between non-metal and non-metal, while electrovalent bond, that is ionic bond, it is always between a metal and a non-metal. Now, second one, it is always formed because of the mutual sharing of electrons, because non-metals always tends to share electron between them. That's why covalent bond is always sharing of electron. While covalent bond, it is always because of the total transfer of electrons. And third one, this bond is weaker bond. Why it is weaker? Because this bond is between non-metal and non-metal. That's why no charges are there, and that's why the force of attraction is comparatively weaker than the ionic bond. Now come to ionic bond. The bond is comparatively stronger. Why it is stronger? Because after donating electron, metal always acquire positive charge and non-metal always acquire negative charge, and because of these opposite charges they tend to attract each other with greater force. That's why this bond is stronger. Now come to fourth point. Because of the weak bond, the melting point and boiling point of these compounds are generally low. They having low melting and boiling points, but because of the strong bond, in case of ionic, they have high melting and boiling point. Generally, these compounds are found in nature in the solid state. Now fourth point, covalent bond is generally non-electrolyte. Non-electrolyte means they never allow electricity to pass through them, either in the molten or in aqueous state. They are poor conductor of electricity. But in case of electrovalent, because of their ions, as the name indicates, they have ions, and because of these ions they are good electrolyte, because they allow the electricity to pass through them and they decompose into their respective ions, but only in case of molten or aqueous state. But in case of solid, they can also poor conductor of electricity. That means they are not passing electricity through them. Now come to electron dot structures of covalent compounds. In your syllabus, there are several compounds starting from the elementary, that is hydrogen gas. How to write the electron dot structure whenever there is question related to in your board paper. Suppose hydrogen gas, we have to write the electron dot structure of hydrogen gas. First of all, we will write atomic number of hydrogen and electronic configuration, that is 1. It requires how many electron in the first shell to become stable, that is 2. That means it should acquire one more electron from another hydrogen atom. In this way, two hydrogen come together and this hydrogen will share one electron from this second hydrogen. In this way, this first hydrogen now have 2 electrons. In the similar way, the second hydrogen will also share 1 electron from the first. In this way, the second atom has also 2 electrons in the outermost shell, and in this way both can attain stability, and there is a bond between these two hydrogen atoms. It depends how many electrons they have shared. If they have shared only one pair of electron, they will have single bond, and if they have 2 electrons shared, they will have double or triple bond. Now in case it has only one shared electron, that means it has single bond, and final product can be written as H2. In the similar way, if oxygen is there, oxygen atomic number is 8, electronic configuration is 2, 6. Now they have how many electron in the outermost shell? That is 6. 2 electron in the outer side and rest of the 4 electron in the inner side. And similarly, to another hydrogen atom has 6 electron. Now this oxygen has deficient of 2 electron only. It can share 2 electron from the another oxygen. In this way, this first oxygen will acquire 8 electron in the outermost shell. Now similarly, this second oxygen also share its 2 electron, and in this way it has also 8 electron in the outermost orbit, and they are sharing 2 pair of electron. That's why they have double bond between the two oxygen atom, and final product becomes O2. Now come to third is nitrogen. Nitrogen atomic number is 7. Electronic configuration is 2,5. That means it requires 3 more electron to acquire stable configuration, and it has 5 electron in the outermost shell. You can show these 5 electron like this, and another nitrogen also have these 3 electron and 2 this. Now this nitrogen share 3 electron from the second nitrogen, and similarly this second nitrogen also share 3 electron from the first. In this way both the nitrogen has now 8 electron in the outermost shell, and now they have acquired stable configuration. But now they have shared 3 pair of electron shared. That means the number of bond become 3. 1, 2 and 3. And the final product, it is N2 only. This N2 means they have 2 nitrogen atoms, and this triple bond means they have shared 3 electrons with each other. Now come to fourth, that is chlorine. Chlorine means atomic number is 17. Electronic configuration is 2, 8, 7. That means they have 7 electrons in the outermost shell. They may have 7 electrons, and another chlorine also have 7 electrons. Now this first chlorine will share 1 electron to become 8 electron, to have 8 electron in the outermost shell, and this second chlorine also have 1 more electron from this first one. Now it has also 8 electron, and they have shared only 1 pair of electron. That means again they have single bond between them, and the final product is Cl2. Now come to fifth compound, that is hydrogen chloride. In this, 2 different atoms are combining. First is hydrogen, atomic number is 1, electronic configuration is also 1, and second one is chlorine. Chlorine atomic number 17, electronic configuration is 287. The first hydrogen, it requires only 1 electron to attain stability, while chlorine has 7 electron, and it also requires 1 electron to attain stability. Now hydrogen only 1 electron, and chlorine has 7 electrons. Now first hydrogen will share 1 electron to become stable, and now chlorine can share 1 electron to become stable. Only 1 pair of electron has shared, that means single bond between H and Cl, and finally it becomes HCl. Similarly, now water. This water, hydrogen atomic number is 1, oxygen atomic number is 8, electronic configuration is 2, 6. But in this case, hydrogen wants only 1 electron, but oxygen, it requires 2 electron. That means 1 oxygen will combine with 2 more hydrogen atoms. That means oxygen has these 6 electron. Hydrogen will have 1 electron in the either side. This hydrogen will share 1 electron to become 2 electron in the outermost shell, and this hydrogen also have now 2 electron in the outermost shell. Now it's term for oxygen. Oxygen also share 1 electron from each hydrogen atom to become stable, and now all 3 atoms have acquired stability, and now the structure becomes H, single bond O, and H, and finally it becomes H2O. And in this way you can show the electron dot structures of the elementary compound of the covalent.